Hello everyone, we'll solve problems on Venturimeters in this session. There are cases like horizontal Venturimeter and vertical Venturimeter. Both of these are covered in this session. We'll straight away go to problems. Okay, an oil of specific gravity 0.8 is flowing through a Venturimeter having inlet diameter 20 cm, throat diameter 10 cm. The oil mercury differential manometer shows a reading of 25 cm. Calculate the discharge of oil through the horizontal Venturimeters take CD. Now whatever derivation that we have done in last class, it was horizontal Venturimeter. Because of that, we can straight away use that equation. Now, given data, specific gravity of oil is given 0.8. It is a mercury which is used. Because of that, SM or a higher specific gravity is equal to 13.6. A reading of differential manometer X we have represented in the last class. It's equal to 25 centimeters. Now, okay, difference of pressure head H equal to, you know that now, SM by S or SH by SO minus 1. Now if you substitute 25, 13.6 divided by 0.8 minus 1 centimeters of oil, and this comes out to be equal to 400 centimeters of oil. Now diameter at inlet is given to be 0.2 meters or 20 centimeters. Because of that, I'll calculate A1 as pi d squared by 4, which comes out to be 314.16 centimeters square. D2 is given to be 10 centimeter. Because of that, A2 comes out to be 78.54 centimeters square. So these informations are needed as A1, A2, then CD. Okay, now applying our equation, which is equation for flow in Venturimeter, which is given by Q equal to CD A1 A2 root 2 GH divided by A1 squared minus A2 squared. This is misprinted anyway. This is A2 squared. Now if I substitute, CD is 0.98, fine. A1 I have 314, A2 I have got 78.54 into root 2 G, because I am using everywhere centimeter, 981. You should be very careful, because if you are using meters, then it is 9.81. If you are using everywhere centimeter, it has to be 981 into this head we have worked out as 400 centimeter. Then A1 squared minus A2 squared. This gives you a value of, I'll calculate, 21421,375.68 divided by 304. That comes out to be 7. I'll write here 70,465 centimeter cube per second. That is the final answer. Now if you want in liters per second, you know that 1000 cc is 1 liter. Because of that, it becomes 70 point maybe 465 liters per second would be the final answer. So that's how the problem is solved. So if you overall look at the problem, this is the heart of the solution, wherein you should know discharge through venturimeter is given by CD A1 A2 root 2 GH divided by A1 squared. A1 A2 are quite simple if the diameters are given. The only important thing is G and H. G you should know how to or which units have to be used. H, which is given by this equation, right, x into bracket Sm by S minus 1, right. So mercury or manometric specific gravity. Here the specific gravity of liquid which is flowing through the venturimeter minus 1. Okay, with this note we'll go to the next problem. Okay, here horizontal venturimeter, once again it is horizontal, fine, with the inlet diameter 20 centimeter. Okay, 20 centimeter, and the throat diameter 10 centimeter is used to measure the flow of specific gravity 0.8. The discharge of oil through the venturimeter is 60 liters per second. Almost similar data, but the way the problem is put is something different. The discharge is given. Find the reading of the oil mercury manometer. Take CD equal to 0.98. That is the problem now. D1 equal to 20 centimeter, A1 is 314.16, D2 10, because of that it is 78.54, CD is given, Q is also given, it is liters per second given, 60 liter per second, but we know that 1 liter equal to 1000 cc, because of that 60 into 1000 centimeter cube per second. This is the data given. Now you know that equation, we will solve. Using the equation Q equal to CD A1 A2 root 2 GH, I'll substitute everything. Q is given, that's why it is 60 into 1000. Here substitution mistake is there. It is 0.98. Sorry, this should have been 0.98. A1 A2 root 2 GH. This H has to be found, because of that it is kept as it is. And if you simplify, you will be getting root H as 17.029. H will be equal to 289.98 centimeters of oil. That is the thing. But H is given by x into bracket SH by SO or Sm by S minus 1, wherein we'll substitute H. Sm is mercury, S naught is 0.8. The reading X can be calculated as 18.12 centimeter. So reading of oil mercury manometer would be 18.12 centimeter. Now from this, what you should understand is directly the discharge may not be asked, but some other data is given and some other data is asked. So you should be knowing that this is the heart of the equation, heart of the problem or venturimeter problems. They may give you anything and then they may ask you. And one more equation that you should be knowing is this. Knowing these two for horizontal venturimeter, it is easy to solve. Okay, we'll go for the next one. Okay, the inlet and the throat diameters of horizontal, once again it is horizontal venturimeter, because of that there shouldn't be any problem. 30 and 10, diameter of the pipe is 30, throat diameter is 10 cm. It's obvious, they have not mentioned explicitly, but it is understandable. The liquid flowing through the venturimeter is water. The pressure intensity at inlet is 13.734 Newton per centimeter square. P1 is given, while the vacuum pressure head at the throat is 37 centimeters of mercury. P2 is given as that. Now find the rate of the flow. This is first part of the problem. Here H is not given. H you have to calculate, which is nothing but P1 minus P2 by gamma. That pressure head has to be calculated. It is given indirectly and used in the same equation to get the discharge. Now next they have asked is, assume that 4% of the differential head is lost between the inlet and outlet, inlet and the throat. Find also the values of CD for Venturimeter. That is the question. Okay, 4% of the head is lost. See, if you got original H as the head, original head difference in or pressure difference between pipe and throat is H, and then something like some head, 4% of the head is lost, right? So what is that remaining head is nothing but H minus HF. Now if you compare this with the original head, this becomes a CD. So CD is nothing but the indicator of energy loss, right? Anyway, we'll solve the problem in thorough manner. Let it be there like that. Okay, here diameter at inlet D1, because of that A1 is found. Fine, A1 is found. D2 is given, because of that A2 is found. P1 is given. Here it is different from the earlier problems. This is all fine. P1 is given as 13.734 Newton per centimeter square. Now if I want the pressure to be in meter square, this centimeter has to be divided by, in this case it has to be in the numerator, 100 and 100, that is 10 raised to 4. So 13.734 into 10 raised to 4 Newton per meter square. I hope you can understand. It is in Newton per centimeter square, that is to say centimeter. Now convert this into meter means what? Centimeter has to be divided by 100. This centimeter should also be divided by 100. So to say this is squared. This is nothing but the 10 raised to 4 multiplier, which converts Newton per centimeter square to Newton per meter square. Okay. Now therefore pressure head, now P1 by gamma or P1 by rho G, right? So P1 is Newton per meter square, it is there. This Newton per meter cube, rho G, or if you actually substitute, because it is given that water is flowing, rho is 1000 kg per meter cube, G is 9.81. If you call it as gamma, it will be 9810 Newton per meter cube or 9.81 kilonewton per meter cube, right? Now if you look at the numerator, it is in newtons and meters cube, that's why it is 9810 Newton per meter cube, or rho G substitution you can do. Now with this, P1 comes out to be 14 meters of water. Now P2 by gamma is given to be minus 37, and moreover they have specified it as minus 37 centimeters of mercury. Now this has to be mercury. Okay, now this is equal to minus 37, 13.6, right? 13.6 is the specific gravity, right? Multiplied by, divided by 100, because this is 37 centimeters is there, that's why you have to divide by 100 so that it becomes meters. Okay, it comes out to be minus 5.032 meters of water. Now differential head H between inlet and throat, it will be P1 minus P2. In terms of head, it will be 14, the earlier one, minus, it is minus because of that minus of minus 5.03. So it becomes 19.032 meters of water, or in centimeters if you want, right? It will be 1903.2 centimeter. This is H. Now coming back to our original idea that CD is square root of H minus HF by H. Yeah, in earlier slide I told you something different. I don't know. Sorry. Okay. This is a comparison of Q theoretical, right? CD is what? Q actual divided by Q theoretical. If you compare these two, the ratio is equal to CD. Now actual is given by what? CD A1 A2 root 2 GH divided by square root of A1 squared minus A2 squared. Q theoretical is given by plane, that is A1 A2 root 2 GH divided by A1 squared, square root of A1 squared minus A2 squared. The same equation if you put, that's why CD comes out to be root of H on the top, head lost, after losing the head. In the denominator it is before losing, that's why this square root comes, right? HF is equal to 4% of the head lost. Now 4% of 1903 is 0.7613. Because of that the CD comes out to be 0.98. Okay. Now discharge is given by CD A1 A2 root 2 GH by, now everything is known here, 0.98, 706, 78.54, root 2, G is in centimeter, H is in 1903 centimeters divided by A1 squared minus A2. If you do all that, you will be getting 149692.8 centimeter cube per second. If you divide by 1000, you will be getting liter per second. If you divide by 1000 once again, you will be getting meter cube per second. So that is what the answer is put, 14969 meter cube per second as the discharge. So slightly different idea in this problem. So CD is given by root of H minus HF by H. H is the original head lost is HF. So after losing the head, whatever remaining head is there, that divided by original head, that under root will be giving you CD. Otherwise this equation you know. Only thing is you have to take care of the units. That's all. Okay, next. Okay, here one problem on vertical Venturimeter. If you can understand this, any inclined Venturimeter can also be analyzed. Only problem in this case is you will not be able to use a ready-made equation. Whatever we have used, that is for horizontal case. Because of that, what happens is you have to go by fundamentals. Fundamentals in the sense you have to apply continuity equation, you have to apply Bernoulli's equation and then solve the problem. We'll see all those details. We'll read the problem first. In a vertical pipe, conveying oil of specific gravity 0.8, two pressure gauges have been installed at A and B, where the diameters are 16 and 8 centimeters respectively. They have not mentioned that it is a Venturimeter, but the similar effect has been brought by reducing the cross-sectional area. The point A is 2 meters above point B. The pressure gauge readings have shown that the pressure at B is greater than that at A by 0.981 Newton per centimeter square. Neglecting all the losses, calculate the flow rate. This is first. Then, if the gauges at A and B are replaced by tubes filled with the same fluid as of point 8 and connected to a U-tube manometer containing mercury, calculate the difference of level mercury in the two limbs of U-tube. Okay, slightly involved problem, but it is purposely taken so that you can understand the intricacies of the problems involved. Okay. We'll keep it there. Okay, this is the diagram now. You can see that it is 16 centimeter at the inlet, 8 centimeter at the throat, so to say. Right? We are interested in these two parts. This is point A, point B. Let us say the difference in level is given to be 2 meters. It's clearly said A is above point B. Okay, now putting on all the data, specific gravity of the oil that is flowing inside this is 0.8. Therefore, density becomes rho equal to 0.8 into 1000. You know how to convert. It is 800 kg per meter cube. Diameter at A is 0.16. A1 becomes 0.0201 meter square. Diameter at point B is 8 centimeter, 0.08 meters. A2 becomes 0.005026 meter square. Yeah, I have to tell this. When the number becomes too small like that, you have to use more of the significant digits so that the value becomes fairly correct. Otherwise, if you just use one digit, the answers may not match. So take care that you will be using good number of digits after a significant value. Difference of pressure PB minus PA, right? PB minus PA will be equal to 0.981 Newton per centimeter square. It is given in the problem. The pressure gauge readings have shown that the pressure at B is greater than point A with 9.981. So PB minus PA is given as 0.981 Newton per centimeter square. Okay. Now centimeter square, if I want to convert meter square, I have to multiply by 10 raised to 4. Because of that, it becomes 9810 Newton per meter square. That is PB minus P. Now head, if I want to calculate difference of pressure head, H equal to, because we need that in the problems. So H becomes PB minus PA divided by rho G. The rho G we have to use, right? Because it is meters, I have taken G as 9.81. A rho is already calculated in the beginning only. Same thing if you use, you will be getting 1.25 meters of oil that is flowing, liquid that is flowing. So that is H is equal to 1.25 meters. Okay, now further, okay, here applying Bernoulli's equation between A and B. So point A and point B, the level difference is given. Now we'll have to apply Bernoulli's equation, taking the reference line passing through point B. We have, so if this is the reference, ZB or ZB will be equal to 0, ZA will be equal to 2 meters. Okay, that's how we have substituted here. P1 by gamma, that is PA is taken as that. PA by gamma. Then slight adjustment, PB by gamma is taken on this side because we know the difference in head, plus ZA minus ZB equal to VB squared minus VA squared by 2Z. Okay, you can understand this adjustment. Now PA by gamma minus PB gamma, this difference in head is calculated. PB minus PA is calculated. Here it is PA minus PB, that's why minus 1.25. This 2 is there, equal to VB squared minus VA squared by 2Z, right? So this is, let us call it as equation 1. Now applying continuity equation at A and B, we have A1 V1 equal to A2 V2 corresponding to A and B, that's why it is given this way. Now you know the areas because it is 16 and 8, right? Double it is, because of that the area ratio will be squared up because of that, or if you even substitute, you will come to know that it will be equal to 4 times VA. So VB is equal to 4 times VA. Now substituting the value of VB, that is VB is equal to 4 VA in equation 1, we get, look at that, what we have done, plain substitution it is. This equation is taken there. 0.75, then VB is substituted as 4 VA, because of that it is 16 VA squared by 2Z minus VA squared by 2Z. So in this whole analysis, so V capital A it is, VA comes out to be 0.99 meter per second, that is the velocity. Now Q is given by A into V. So area is known already, multiplied by the velocity, right? The order of substitution may be slightly different, but anyway the Q comes out to be this multiplied by this so many cubic meter per second, right? It is almost 0.99, because of that it is almost the same cubic meter per second. Okay, now next part of the problem, they have asked what is X. So we'll start difference of level of mercury in U2. This is what is asked. So what to do? Let X be the difference. Now H will be equal to X into bracket Sm by S naught minus 1. So H is equal to PB minus PA. You know that difference here this H is, if I write the equation for this whole thing, H is equal to PA by gamma plus ZA minus PB by gamma plus ZB. If you simplify, you'll be getting 0.75. Now this I'll use it as a 0.75 in this equation, equal to X into bracket 13.6 by 0.8 minus 1 to 16x. X becomes this. Okay, with this I think we'll stop. Thank you.